Good morning everyone. So in the last lecture we have discussed about what? Integration by parts, correct? Now today we are going to revise integration by partial fractions. Now in this you will get three types of examples. Okay, what are partial fractions and what are rational function, what are fractions, all I have explained in your regular lectures. Now we will just revise what are the different types and we will solve some important numericals. So integration by partial fraction, you will get three types of example. So basically which procedure is to be followed, it will based on what denominator has. In the type number 1, denominator has denominator consists of what? Non-repeated linear factor. Denominator consists of what? Non-repeated linear factors. What do you mean by non-repeated linear factors? See, if you consider this fraction, denominator has two factors, x minus a, x minus b. What are the powers? What is the power here? X minus a, what is the degree? 1. X minus b, what is the degree? Degree of variable. It is what? 1. So it's a linear factor. Plus, is this repeated? No, it's a non-repeated linear factor. So whenever you will get such type of example and whenever you are supposed to do integral of this, first you need to convert this fraction into what? Partial fraction. How you will convert? You need to assume, you have to allot a constant to each individual non-repeated linear factors. So x minus a, x minus b, these are the two factors. So I have allotted constant to this factor, a upon x minus a plus b upon x minus b, right? Once you get a and b, see, you have to do integral on left hand side. That means what? Right hand side is to be integrated. So once you get a and b will be what? Constant. The integration becomes easy, right? So this is the type number 1, denominator consists of non-repeated linear factor. Next, type number 2 is denominator consists of repeated linear factors. Denominator consists of what? Repeated linear factors. See, factors are still linear. You can observe here, x minus a, it's a factor. It's a linear factor. X minus b, it's another linear factor. But x minus a square is there, x minus a bracket square, so it becomes what? Repeated. So whenever you will get repeated linear factor, you will, whenever you want to do integral, you will convert this fraction into what? Partial fraction. How you will convert? As per procedure, one constant is to be allotted for non-repeated linear factor, so it will be c upon x minus b. Now whichever factor is repeated, it's a repeated, so you have to allot two constant. Now while allotting two constant, it is a upon x minus a and second b upon x minus a bracket square. Okay, so this is the type number 2. Then third case is there, denominator consists of quadratic factor. Now what do you mean by quadratic? See, this is linear factor, is it correct? It's a linear, but this second factor here, it's a quadratic factor, correct? So whenever you will get a quadratic factor in the denominator and if you are supposed to do integral, you will convert this into partial fraction. How you will convert? See, x minus a, it's a linear as well as it's a non-repeated linear factor, so one constant to it. Now this is quadratic. Being quadratic, while converting into partial fraction, two constant you have to allot, but while allotting constant, it is bx plus c upon x square plus bx plus c. See, why here bx plus c? If you observe any partial fraction, see, for example, consider this fraction. What is degree of numerator here? 0. What is degree of denominator here? 1. So 0 less than 1. By 1 it is less. Similarly, if you observe this partial fraction, what is degree of numerator? 1. What is degree of denominator? 2. It is less. Similarly here it is 0. What is degree here? 1. So degree of numerator should be less by 1 as compared to degree of denominator, right? So this is the concept of converting given fractions into what? Partial fraction and do the integral. Now let us solve some example so that this procedure will be clear to you. It is one of the important topic from integration chapter. Definitely you will have question in boards, CET as well as in JEE. Okay. So let us see first example. Now we have seen the different types. So based on the type, you have to follow the respective procedure. For example, first is, let us start with some simple so that you will get idea and then we will increase the difficulty level. So first one is x square, integral x square plus 2 divided by x minus 1, x plus 2, x plus 3 dx. So this is the integral to be solved. Now it is easy that example, it is from the topic integration by partial fraction. By looking at the example, you will come to know that it's an example from the partial fraction topic. Okay. Now whenever you will get example based on partial fraction, first you need to observe the denominator. Okay. So in your syllabus you are having 3 types which we have discussed previously. So out of the 3 type, this is your denominator. Denominator consists of what? X minus 1, x plus 2, x plus 3. So denominator consists of, I can observe it's a linear factor. These are all linear factor plus it's a non-repeated. It's a non-repeated linear factor. So it becomes which case? Non-repeated linear factor. It becomes which case? It's a first case. Denominator consists of non-repeated linear factor. Okay. Now what is the procedure? You have to allot single constant to each non-repeated linear factor. So how many non-repeated linear factors are there? 3, x minus 1, x plus 2, x plus 3. So let us convert given fraction into partial fraction. So x square plus 2 upon x minus 1, x plus 2, x plus 3 is equal to, okay, to each linear factor you have to allot one constant. So how I can write? This is equal to a upon x minus 1 plus b upon x plus 2 plus c upon x plus 3. See, what is the example? You have to find integral of this. Finding integral of this is nothing but finding integral of this. Okay. Now these integrals are easy. For example, if you get a is equal to 2, this first term it becomes what? Integral 2 upon x minus 1 dx. So integral is easy. It is what? 2 log x minus 1. Correct. So that's why we are converting given fraction into partial fraction so that integration becomes easy. Now how we will find ABC? Next step is you have to find ABC. How you will find it? Okay. So let us take LCM here. What will be LCM here? LCM will be x minus 1, x plus 2, x plus 3. This will be LCM. Correct? Now what will be changes in numerator? A into. Here it is x minus 1 is there. What is missing? X plus 2, x plus 3. Plus b into. X plus 2 is there. What is missing? X minus 1, x plus 3. Plus c into. X plus 3 is there. These two terms are missing. X minus 1, x plus 2. Is it correct? Right? So, see, on the left hand side same fraction is there. Denominator is same. You can equate the numerator. So by equating numerator, what you will get? You will get x square plus 2 is equal to a in bracket x plus 2 x plus 3, b in bracket x minus 1 x plus 3, c in bracket x minus 1 x plus 2. Correct? Now we need to find out ABC. We need to find out ABC. Okay. How you will find ABC? See here, if you want to find out A, this is the A term, right? In this term you are having A. What we will do? We will convert B and C to 0. If B term becomes 0, C terms become 0, you will get value of A, right? So I am writing here, to get A, put x is equal to, right? Just a minute. Okay, to get A, you have to convert B and C term to 0. What is common in this? Common is x minus 1, x minus 1, right? So to get A, if you want to find out A, you have to make B term 0, C term 0. So find common factor. What is common factor? X minus 1, x minus 1. So I will put x is equal to 1. See here, I am putting, if I am putting x is equal to 1, 1 minus 1, this term will become 0, 1 minus 1, this term will become 0. Hope this is clear. So if you are putting x is equal to 1, what will be A? See, this is 1 square plus 2, it will be 3, A in bracket, 1 plus 2, 3, 1 plus 3, 4. This 3 and 3, this will get cancelled. So what is value of A? 1 by 4. What is value of A? 1 by 4. Correct? Now, let us find out value of B now. Let us find out value of B. Okay, value of B. So to get B, again same approach. If you want to find out B, you have to make A term 0, C term 0. Okay, what is common in A and C? What is common? See, x plus 2, x plus 2. Correct? So to get B, I will put x is equal to minus 2. So minus 2 square. What is minus 2 square? It will be 4. 4 plus 2, it will be 6, is equal to A term, it will become 0, minus 2 plus 2, right? No need to write, right? Next, B in bracket, we are putting minus 2, minus 2 minus 1, minus 3, minus 2 plus 3, 1. Again C term, it will become 0, right? So what about value of B? B will be equal to 6 upon minus 3, minus 2. Correct? You are getting B as minus 2. Okay. Next, to get, okay, we will write here only. To get C, what you have to put? Tell me. Put x is equal to. If you want to get value of C, you have to make A term 0, B term 0. What is common in this? X plus 3 is common. So what you will put? You will put x is equal to minus 3. So if you are putting x is equal to minus 3 square, what is minus 3 square? 9. 9 plus 2, it is 11. A will become 0, B will become 0, C in bracket, minus 3 minus 1, minus 3 plus 2. So minus minus, it will get cancelled. What is value of C? You are getting 11 by 4. So this is the procedure to find values of ABC, right? See here, again I am repeating. First, if example is of integration by partial fraction, observe the denominator. Denominator consists of what? Non-repeated linear factor, that is the type 1. If you are getting type 1 example, you will convert this into partial fractions like this. You have to allot one constant to each non-repeated linear factor, a by x minus 1 plus b by x plus 2 plus c upon x plus 3. Take the LCM, equate the numerators. Once you are equating the numerators, you have to find values of a, b, c. Now, let us come to integral, right? What is our, see what you want to find out, you have to find integral of this. Finding integral of this is nothing but finding integral of this, okay? So, I will be equal to a upon x minus 1, what is a? 1 by 4 plus b upon x plus 2, what is b? Plus c upon x plus 3 dx, correct? So, let us find integral. It will be 1 by 4 log x minus 1 minus 2 log x plus 2 plus 11 by 4 log x plus 3 plus c, right? So, this is how you will convert the given fraction into partial one, and this is the procedure to find integral, okay? So, first example is clear. You can note it down, you can pause the video and solve this example. Okay, let us see the second one. Integral 12x plus 3 upon 6x square plus 13x minus 63 dx. Integral 12x plus 3 upon 6x square plus 13x minus 63. Now first observe whether you can find factors of this or not, okay? So 6x square plus 13x minus 63. So what is 63 into 6? It will be minus 378. So you have to find factors of 378, minus 378, such that sum should be plus 13. Sum should be plus 13. So what are the factors? How you will find the factors here? 2 into. We know the procedure. 2 into 2 ones are 2. Then 17. Okay. 2 into 3 into 2 into 3 into 7 into 9. Okay. So what are the factors? Factors are 7 into 2, 14, 9 into 3, 27. Now adjust this side. Here it is plus 13. So plus minus. Okay. So what will be factors here? So 6x square plus 27x minus 14x minus 63. What you can take common? You can take 3x common, in bracket it will be 2x plus 9, minus you can take 7 common, in bracket it is 2x plus 9. What are the factors? Factors are 2x plus 9, second factor is 3x minus 7. So whatever integral you need to find out, what integral you have to find out? You have to find integral of 12x plus 3 upon. Now I am replacing this quadratic polynomial with these factors. Factors are 2x plus 9, second factor 3x minus 7 dx. This is our example. Now how you will solve this? Okay, observe the denominator. Denominator consists of what? Are the factors linear? Yes. Are they non-repeated? Of course these are non-repeated. Is there any square or right? Square है क्या वहाँ पे नहीं. So these are non-repeated linear factors. So let us convert into what? So again type 1 example. It's a type 1 example. So convert this into partial fraction. So 12x plus 3 upon, what is our procedure? 2x plus 9, 3x minus 7 is equal to a upon 2x plus 9 plus b upon 3x minus 7. Correct? Okay. Correct? Okay. Again, see, you have to follow the same procedure. Let us do the LCM, or now as there are only two terms, you can do the cross multiplication. It will be a in bracket 3x minus 7 plus b in bracket 2x plus 9 divided by 2x plus 9 3x minus 7. Correct? So equate the numerator. What is the numerator? 12x plus 3 is equal to, what is the numerator? A in bracket 3x minus 7 plus b in bracket 2x plus 9. Is this correct? Okay. So what is the next step? You have to find values of a and b. Right? Once you get values of a and b, just it's an integral of this term. So how you will get values of a and b? So what is our procedure? We make other term 0. For example, if you want to get a, अगर a find out करना है, you have to convert b term to 0. Now when b term get 0, when 2x plus 9 will get 0. What about x? Minus 9 by 2. So when you are putting x is equal to minus 9 by 2, at that time b term will get 0 and you can find value of a. Okay. So let us put x is equal to minus 9 by 2. 12 in bracket minus 9 by 2 plus 3 is equal to a in bracket 3 minus 9 by 2 minus 7. B term will be 0. Now let us solve this. So this is 6. Okay, further we need to calculate this. So this is minus 54 plus 3 minus 51 is equal to, correct? This will be a in bracket minus 27 by 2. Right? So what will be a? Minus minus, it will get cancelled. A will be 51 by 2 upon 27. 3 9s are, so it is 34 by 9. Is it correct? What is value of a? 34 by 9. What is value of a? 34 by 9. Right? A is 34 by 9. Correct. Now let us find out value of b. How you will get value of b now? Okay, what is wrong here? See, this -7 we have missed out. Okay, that's why it is minus 27 by 2 minus 7 by 1. Now it is correct. So minus 51 is equal to a in bracket. So this will be minus 27 minus 14 by 2. So minus 51 will be equal to a into, how much is this? This will be minus 41, correct? Minus 41 by 2. So minus, now it will get cancelled, and a will be how much? 51 into 2 by 41. So it will be 102 by 41. Now it is correct. Right? We have missed out it 7. 102 by 41, correct? Right. So this is how you will find out A. Now let us find out B. So to get B, what you have to do? You have to make A term 0. That means you have to make 3x minus 7 as 0. 3x will be equal to 7. You have to put x is equal to how much? 7 by 3. You have to put x is equal to 7 by 3. So to get B, put x is equal to 7 by 3. Correct? So 12 in bracket 7 by 3 plus 3 is equal to A will be 0. Now see the B term, B in bracket 2 into 7 by 3 plus 9. Right? So 3 4s are 7 into 4 28, 28 plus 3 31 is equal to B in bracket. How much is this? 14 by 3 plus 9 by 1. Right? Do this. So this is 14 plus 27, 41 by 3. So how much is B? B you are getting as 93 by 41, correct? B you are getting it as 93 by 41. Okay. See here, B. What is value of B? B will be equal to 31 into 3. What is 31 into 3? 93. 93 by 40. So these are values of A and B. So integral becomes I will be equal to, right? So I means what? You have to find integral of this, right? Integral of this. See, finding integral of this is nothing but finding integral of this, correct? So I will be equal to integral integral A upon, what is A? 102 by 41 upon 2x plus 9 plus B upon 3x minus 7. What is B? 93 by 41 upon 3x minus 7 dx. Is it correct? Right? Is this correct now? So tell me what will be integral. Yes, write the integral. So 102 by 41 you can take outside, log of 2x plus 9 divided by 2. What is coefficient of x? 2. You have to divide because we are doing integrations. Plus 93 by 41 log 3x minus 7 upon 3 plus c. Right? So this is how you will find integrations by partial fraction. So hope both the examples are clear. Okay, so hope both, see this chart is very important. whatever we have discussed in the first slide. So once you get the example of partial fraction, see the type, whether it is type 1, type 2, type 3, right? So both the example which we have solved, those are of type 1, that denominator has non-repeated linear factors. Now let us see some examples on type 2 and then type 3. Okay, see the type number 2. What is the type number 2? Type number 2 is what? Denominator consists of repeated linear factors. Okay, see, factors are linear, but one or two factors will be repeated. It will be what? Repeated. Repeated means what? Square will be there. Okay, repeated means what? Square. Okay, so let us see next example. Example number 3. So example is I is equal to integral 3x minus 2 upon x plus 1 square into x plus 3, not 3x, it is x plus 3. 3x minus 2 upon x x plus 1 bracket square into x plus 3, right? So see what is denominator and how we will find the partial fraction, whether it is type 1, type 2, type 3. Okay, so if you observe the denominator has what? See, factors are linear. What are the linear factor? X plus 1 is there, second is what? X plus 3. X plus 3 is non-repeated because square is not there, but x plus 1 it's a repeated factor and as well as it's a linear factor. So it's a denominator consists of repeated linear factor. It will be case number 2 or type number 2. How you will find the partial fraction? Okay, see here, 3x minus 2 upon x plus 1 square into x plus 3 is equal to, this factor is repeated, so you have to allot two constants to it, a upon x plus 1 plus second constant. While allotting second constant, you have to take square of this, plus x plus 3, it's a non-repeated, so one constant will be enough, c upon x plus 3. Okay, so this is the important step. If you go this, if you are making this wrong, then it will be difficult. Okay, so this step is important. Okay, so this step is going to be important. Okay, I am putting star mark here. Now, again, procedure will remain same. Let us take LCM. What will be LCM? Tell me. LCM will be x plus 1 square into x plus 3. Is it correct? This will be LCM. Now, if this is the LCM, what will be changes in numerator? A into whatever terms are missing, just write it. X plus 1 is there. What is missing? 1 x plus 1 is missing. Second x plus 3 is missing. Plus B into x plus 1 square is there. This term is missing. So you will write here x plus 3. Plus C into x plus 3 is there. What is missing? X plus 1 square. Is it correct? Is the second step clear to everyone? You have to take LCM. What will be LCM here? X plus 1 square into x plus 3. Now just write the missing term. For example, A to its denominator is x plus 1. What is missing? 1x plus 1 is missing and x plus 3 is missing. Okay. So let us equate numerator. What is numerator here? 3x minus 2. What is the numerator here? Complete. A in bracket x plus 1 x plus 3, B in bracket x plus 3, C in bracket x plus 1 square. Now you have to find A, B and C. Okay. Now for example, let me find out A first. If I want to find out A first, I will make term B, term C 0. Okay, I have to make this B term 0, C term 0. But is there any common thing in this? No. So avoid A first. Let us come to B. If I want to find out B, I will make A term 0, C term 0. Is anything common in A and C? Yes. What is common? X plus 1, X plus 1. So what I will do, instead of finding A first, I will find B. What is common? X plus 1, X plus 1. So I have to put X is equal to minus 1 to make it 0. Okay. Is this step clear? We cannot find out A directly here. Why? There is no common thing in B and C. So avoid A. Consider B. So to find out B, is there any common thing between A and C? Yes. What is the common thing? X plus 1 is there. So to make it 0, I will put X is equal to minus 1. So 3 in bracket. Okay, let us write it directly now. Okay. See, 3 into minus 1, it is minus 3. Minus 3 minus 2. Minus 5. Minus 3 minus 2. Minus 5 is equal to. A term, we are making it 0. Minus 1 plus 1, it will be 0. B in bracket. Minus 1 plus 3, it will be 2. C term minus 1 plus 1, it will be 0. So from this, I will get value of B. What is B? Minus 5 by 2. Minus 5 by 2. Is it clear? Okay. Next, let us find out C. Let us check whether we can find out C or not. To find C, is there any common between A and B? Yes. What is the common thing? X plus 3, X plus 3. So to make A0, B0, what I have to put? I will have to put X is equal to, yes, minus 3. Correct. So let us put X is equal to minus 3. Let us put X is equal to minus 3. So to get yes, to get C, put X is equal to minus 3. Okay, so if I am putting X is equal to minus 3 into 3, minus 9, minus 9 minus 2, it is minus 11. Okay, A term will be 0, minus 3 plus 3, it will be 0, B term it will be 0. Now come to C. C into minus 3 plus 1, minus 2 square. So what about C? Minus 11 by 4. C will be minus 11 by 4. Correct? Okay. So we have done with value of B. We have done with value of C. Now how you will find value of A? Okay. So question is now how you will find value of A? Okay. See, actually what is our procedure, that if you want to find out A, there should be common between B and C. But there is nothing. See, no factor is common between B and C. No term is common between B and C. So we cannot use our usual procedure. So whenever you get type number 2, you will be able to find two constants. But for the third constant, you have to assume some value of x. So to get A, I will put x is equal to. Okay. Now there are different numbers you can put, but start with 0. Whether we have used 0 or not, हमने 0 यूज किया है क्या? यहाँ पे हमने x is equal to क्या पुट किया है? -1. We have put x is equal to -1. Here we have put x is equal to -3. 0 we have used? No. So what we will do, we will simply use 0 so that calculation will become easy. If 0 is used, go with 1. If 1 is used, go with -1. If -1 is used, go with 2. Right? Likewise. So if 0 is not used, better to use 0. So 3 into 0, it will be 0, 0 minus 2, it will be -2. We are finding what? A. So A in bracket, 0 plus 1, it will be 1, 0 plus 3, it will be 3. Correct? Now B and C, we have already found values of B and C. We cannot write B into 0, C into 0, because we are putting x is equal to 0 here. Plus B, what is B? Minus 5 by 2. 0 plus 3, what is 0 plus 3? 3. Correct? Next, plus C, what is C? Minus 11 by 4 into 0 plus 1 square, 1 square it is 1. So this is how you have to find value of, this is how you have to find out value of A. Correct? Okay. See what happened, most of the student, they will put x is equal to 0 and they will not write B and C term. Okay, it will give you wrong value of A. Correct? Because if when you are putting x is equal to 0, B and C, whether they are getting 0, no. Okay, it is 0 plus 3. It is not 0 into 3, it is 0 plus 3. 0 plus 1. Correct? Okay, so let us solve this. So this will reduce to what? Minus 2 is equal to, this is 3A. This is minus 15 by 2 minus 11 by 4. Correct or not? Please check the calculations. Okay. So minus 2 is equal to 3A. What you can do? See, as per your wish you can solve this. Either you add this or you can take to the left hand side, that will be better. Okay, so we can convert, we can do the addition of all three things. See, minus 15 by 2, when it will come here, it will be plus 15 by 2 minus 11 by 4, it will be plus 11 by 4 minus 2 by 1 is equal to 3. This is 2 by 1. Right, this is the simplest one. What will be LCM? LCM will be 4 into 2 into 2, it will be 30 plus 11 minus into 4 into 4, it will be 8 is equal to 3A. Correct? So this will be how much? Yes, this will be 3. 30 plus 3, 33 by 4 is equal to 3A. What about A? It will be 11 by 4. Okay, is the procedure clear? So this is how you will find value of A, B, C in type number 2. Okay. So let us find now integral. See the integral. See, it's a long example. Okay, so please practice all such examples properly so that it will not be a time consuming. So what about integral now? See, what we have to find out? You have to integral of this. Finding integral of this is nothing but finding integral of this. Is it correct? Okay. So what I am having, I is equal to, first one, A upon x plus 1. What is A? 11 by 4 upon x plus 1 plus B upon x plus 2 square. What is B? X plus 1 bracket square plus C upon x plus 3. What is C? Into what? Dx. Into what? Dx. Okay. Let us solve this now. This is equal to, I will be equal to 11 by 4 into log of x plus 1. Correct? Okay. Now how you will find integral of next term? See, we have written this integral. We have written this integral. How you will find integral of? See, integral of minus 5 by 2 I can write outside. This is 1 upon x plus 1 square dx. How you will find integral? Minus 5 by 2 x plus 1 to the power minus 2 dx. X to the power n. So x to the power n plus 1 minus 2 plus 1 minus 1 upon minus 1, minus minus it will become plus 5 by 2 into x plus 1. This is the integral. Okay. So next term integral, it is how much you are getting? Plus 5 by 2 into 1 upon x plus 1. minus 11 by 4 log x plus 3 plus c. This is your answer. Correct? So hope complete example is clear to you. Again I am repeating. Okay, this type is important. See, mostly the problem will be finding A, and second, most of the students won't be able to find integral of this. Right? It's a simple x to the power n form. Right? So see, whenever you will get example of partial fractions, observe the denominator. In this example, denominator has repeated linear factor. So I will find partial fractions like this, right? Whichever is repeated, x plus 1 is repeated, it will have two constant. Which is non-repeated, it will have single constant, right? Take the LCM, equate the numerator. You can find two constant easily. Okay, you can find two constant very easily using our same method. To find third constant, what you have to do? Check which values are used. If you have not used 0, put it 0. Okay, simple. So while putting 0, don't make b and c also 0, right? So it will be, put x is equal to 0 in this, you will get value of a. Once you get value of a, this is how you will find integral. Okay, see, once you get ABC, an example is very easy, right? Integrals are not difficult at all. This is simply log, this is x to the power n form. Okay, so all the three example is clear. I am giving you some practice example. You can try it at home. Okay, write some practice example. So all the examples are from the same topic, integration by partial fraction. Hope, see, in the last lecture also I have given some practice question. If you have any doubt, you can comment in the below the video. Okay, definitely I will get back to you. So practice questions. Write down practice question. First is question number 1 is integral x square upon integral x square upon x square plus 1 x square minus 2 x square plus 3. Okay, now some students may feel that denominator has a quadratic factor and we have not done like this. Okay, see here, if I am considering x square as t, if I am considering x square as some variable, let's say t, my example becomes what? T upon t plus 1, t minus 2, t plus 3. Is it correct? Right? Now this is which type? Type number 1, that denominator has non-repeated linear factor. So consider x square as some variable. We are not putting substitution, we are not using substitution. We are simply considering x square as t, and I am going to solve with method of type 1. Okay, and then I will replace, while finding integral, I will replace t with what? X square. Right? In the regular lecture, you will find such examples. Right? Okay. Next, second one. Write the second example. Okay, integral 5 e to the power x, integral 5 e to the power x upon upon e to the power x plus 1 into e to the power 2x plus 9, e to the power 2x plus 9. Okay, now how we will solve this example, right? So again it's a examples, it's a combined example of substitution and partial fraction. If I am putting e to the power x is equal to d, here I am using substitution. In first example I have not used substitution, I am simply using some variable for x square. Okay, here we are using substitution. Let e to the power x is equal to t. After differentiating, e to the power x dx will be equal to what? Dt. So my example becomes 5 e to the power x dt, it will be dt, right? E to the power x into dx, it will be what? Dt, upon it will be t plus 1 into t square plus 9. Now tell me, this is which type? Observe the denominator. Denominator, does it has all linear factors? T plus 1 is linear, but what about t square plus 9? It's a quadratic factor. So it's a type 3 example. It's a type 3 example. How you will find integral of this? To convert this into partial fraction. So 5 upon t plus 1, second factor t square plus 9, a upon t plus 1 plus bt plus c upon t square plus 9. Please check our first slide. Quadratic factor bx plus c, whichever is the quadratic factor, there will be two constants, bt plus c, and then you can proceed. See, other procedure will remain same. Do the cross multiplication, find out a and a, b, c, and then find the integral. Okay, so this is second you need to try. Then third one, integral 1 upon sin 2x plus cos x dx. Okay, see how we will proceed with this. This is our example. This is how we need to find out integral. So what I will do, 1 upon, what is sin 2x? 2 sin x into cos x plus cos x, okay, into dx. What I can take common? I can take cos x common. If I am taking cos x common, in bracket it will be, if I am taking cos x common, in bracket it will be 1 plus 2 sin x. Now still I am not able to convert this into what? Partial fraction. What I will do, okay, what I will do, I will multiply, okay, let me write this properly so that there won't be any confusion. This term is cos x. What I will do, I will multiply and divide with cos x. Integral cos x upon cos x into cos x, cos square x in bracket 1 plus 2 sin x. Right? Now what about cos square x? Cos square x you can replace with 1 minus sin square x. Right? See here, cos square x, you can replace this with 1 minus sin square x. What are factors of 1 minus sin square x? 1 plus sin x into 1 minus sin x. So my example becomes cos x upon, instead of cos square x, I am writing it as 1 plus sin x, another bracket 1 minus sin x, and next bracket 1 plus 2 sin x. Right? Now hope you got this. Now you can put sin x is equal to t. So cos x dx, it will be equal to what? dt. See here. How you will proceed further? I will put here cos x is equal to t. I will put here sin x. I will put here sin x is equal to t, cos x dx will be equal to dt. So my example becomes, what I have to find out? I have to find out, see, cos x dx, it will be dt upon 1 plus t, 1 minus t, 1 plus 2t. Now this becomes example of partial fraction. Denominator consists of non-repeated linear factor. You can proceed like type 1 examples, right? So please note down these 3 example, as well as you can note down these points. Okay, so please try to solve. If there is any difficulty you are facing, you can comment in the comment section. Definitely I will get back to you. Right, so this is it for today's lecture. Hope these revision lectures will be useful to you. So first we have revised some special integrals. In lecture number 2 we have revised integration by parts, and this is the third video for integration by partial fraction. Hope with this you will be able to solve integration examples. So thank you everyone.